Welcome to the DIY Honda Garage channel. The DTC P1707 indicates a problem related to the neutral position sensor B circuit, specifically a low voltage condition. This sensor plays a crucial role in ensuring that the vehicle only operates in the appropriate gears when in neutral or park. Located near the transmission, the neutral position sensor sends crucial signals to the powertrain control module, PCM, regarding the vehicle's gear position. If the signals are weak or non-existent, it can lead to various operational issues. This error can occur intermittently or as a confirmed fault, requiring methodical troubleshooting to resolve. Addressing this error involves several steps, including verification of the DTC using the Honda Diagnostic System, HDS, and checking sensor wiring for faults. The neutral position sensor is responsible for relaying the current gear position to the powertrain control module, PCM. This sensor ensures that the engine operates only when the vehicle is in appropriate conditions, such as park or neutral. It is physically located on or near the vehicle's transmission, making it directly involved in gear selection processes. A malfunction or low voltage condition from this sensor leads to the diagnostic trouble code P1707. When the HDS is used to read DTCs, the presence of this fault means there could be issues influencing the vehicle's performance and safety. Quick identification and rectification of this error are essential to maintain vehicle functionality. The possible causes for the DTC P1707 include multiple factors. A faulty neutral position sensor could be directly responsible for sending inconsistent or low voltage signals. Additionally, bad wiring or connections, especially at the sensor or PCM, could lead to erroneous readings. Detachment or corrosion of pins and connectors can also contribute. Another consideration is a malfunctioning powertrain control module, PCM, which may not interpret the sensor data accurately, leading to operational faults. It's essential to investigate each of these areas thoroughly to isolate the cause of the P1707 error. Proper diagnostics will ensure that any component failures can be identified and resolved. Symptoms associated with DTC P1707 can significantly affect vehicle operation. One prevalent symptom is that the engine may not start if it misinterprets gear positioning signals. Additionally, the transmission could become stuck in a particular gear, limiting driving capability. Drivers may also notice the illumination of the check engine light on the dashboard, which signals an underlying issue in the vehicle's systems. These symptoms can lead to unsafe operating conditions and should be addressed promptly. Awareness of these indicators can help in quicker identification of DTCs and expedite repair processes, contributing to overall vehicle reliability. Begin the troubleshooting process by ensuring the vehicle is in the on mode, activating all electrical systems necessary to diagnose the issue. Using the Honda Diagnostic System, HDS, clear any diagnostic trouble codes. This step is crucial because it resets the system states and eliminates potentially outdated fault codes from influencing current diagnostics. After clearing, you should check for any pending or confirmed diagnostic trouble codes once again. If DTC P1707 is confirmed, it signifies a persistent issue requiring further investigation. If it does not appear, it may point to an intermittent fault, necessitating an examination of electrical connections along the neutral position sensor and PCM. Check the diagnostic trouble codes using the HDS once again. Particularly, look for DTC's P0851, which relates to the neutral position sensor A circuit low voltage. If both P0851 and P1707 are indicated simultaneously, it suggests that there could be a broader issue within the neutral position sensor systems. This correlation helps in narrowing down which component or wires may be at fault. should only P1707 appear. Focus will shift to a more isolated inspection of the neutral position sensor B specifically, confirming that it is the root cause of the issue. Gathering all diagnostic data at this stage is imperative for accurate troubleshooting. To determine a possible failure area, turn the vehicle to the off mode and disconnect the neutral position sensor's 4P connector. This step is crucial as it isolates the sensor from the circuit, allowing for accurate testing of electrical inputs. Next, switch the vehicle to the on mode to enable voltage measurement. Using the appropriate testing device, measure the voltage between test points 1 and 2. Noting that test point 1 is the female terminal of the neutral position sensor connector. If the voltage reads around 5.0 volts, this suggests the sensor is indeed faulty and requires replacement. If you receive a different reading, it directs you to further investigations in the wiring and connections. For this step, again, turn the vehicle to the off mode. Jump the SCS line with the HDS for over 1 minute to reset any potential errors. Disconnect the PCM connector E, which is an 80P connector, to ensure there is no interference during testing. Next, check for continuity between test points 1 and 2. Test point 1 is the female terminal number 1 of the neutral position sensor connector, while test point 2 is number 77 of the PCM connector E. If continuity is present, this indicates that the VCC2 wiring is intact, and any issues might relate to the sensor or perhaps the PCM itself. If not, pursue repairs for any open in the VCC2 wire. Restore the connections on the neutral position sensor 4P connector and connect terminals A and B with a jumper wire to facilitate a test. Terminal A corresponds to female terminal number 1, and terminal B corresponds to female terminal number 4 of the neutral position sensor connector. Once this jumper is made, turn the vehicle back to on mode and use the HDS to check the relevant signal parameters. Specifically, confirm that the neutral position sensor 2 indicates around 5.0 V. If this voltage is confirmed, the sensor is faulty and should be replaced promptly. If the voltage is not present, this reveals further issues, either within wiring or the PCM, that need addressing. First, remove the jumper wire from the neutral position sensor 4P connector to reset the connections for proper testing. Then, jump the SCS line with the HDS again for circuit integrity check, ensuring you've waited over a minute for the reset procedure. Disconnect the PCM connector E to create a clean testing environment. Measure continuity between test points 1 and 2, where test point 1 is the female terminal number 4 from the neutral position sensor connector, and test point 2 should connect to body ground. If continuity is established, it indicates a short has occurred in the NSS2 line, and repairs must be instituted in that specific area. If continuity is not detected, the NSS2 line of wiring is free from short issues. Hence, you can proceed to the next step. This final step involves checking for continuity once more. This time, between the neutral position sensor 4P connector and the corresponding PCM connector E. Ensure that both connectors remain disconnected during this process. Specifically, assess continuity between test point 1, female terminal number 4 of the neutral position sensor, and test point 2, PCM connector E, number 68. A successful continuity test here confirms that the NSS2 wire is functioning as intended. If the wires are intact, further investigation will be necessary, including evaluation of the PCM and possibly substituting it with a known good unit to see if the DTC P1707 persists. Proper repairs or replacements can then follow based on the findings of previous tests. After completing all repairs related to DTC P1707, it's essential to verify the repairs made. Recheck for any diagnostic trouble codes using the HDS to ensure that DTC P1707 does not reappear. Confirm operation of all affected systems to warrant the vehicle functions correctly after the repairs. It is also advisable to perform a test drive under varied conditions to ensure no intermittent failures occur during operation. This comprehensive testing not only concludes the troubleshooting process, but also fortifies the reliability of vehicle performance moving forward. Tracking and documenting the repairs will lend insight into future diagnostics if any related issues arise. To prevent future occurrences of DTC P1707 and to maintain vehicle integrity, regular preventative maintenance is essential. Begin with periodic inspections of wiring related to the neutral position sensor and PCM connections to ensure there are no signs of wear, corrosion, or loose connectors. Keeping these connections clean and secure will significantly reduce occurrences of faults over time. Additionally, regular checks on the sensor's contacts will ensure that they remain adequately serviced and free from contamination. Establishing a routine maintenance schedule ensures that all vehicle electrical systems remain in proper working order, contributing to a reliable driving experience, while also enhancing safety. Awareness of maintenance will inherently prolong the lifespan of critical vehicle components. In conclusion, the DTC P1707 signifies a malfunction in the neutral position sensor B circuit, demanding prompt attention for vehicle functionality. The troubleshooting process involves systematic checks of both hardware and electrical systems, ensuring that potential causes are meticulously verified and addressed. Early identification of issues aids in preventing more severe damages and costly repairs down the line. By maintaining awareness of the symptoms and implementing regular preventive maintenance, drivers can enhance the reliability and safety of their Honda Civic. Practicing thorough diagnostics enables mechanics to maintain vehicle health effectively and helps in fostering trust in automotive repair services. Please like and subscribe to the channel. See you next time.